All right, so before I kick this off, basically we're going to be talking about plugins with Jenkins, and I just wanted to get an idea kind of the audience of this so I could tailor a little of what I talk. So first of all, if you could raise your hand if you've installed a Jenkins plugin before into a Jenkins instance. Great. And then also if you could raise your hand if you've developed your own custom Jenkins plugin. All right, so a few people. So just wanted to get a general idea so I could tailor what I talk about here then. All right, so the topic of this talk is providing a first-class user experience with Jenkins plugins. And really what this talk is meant to do is focus on how you can provide a really good experience with the Jenkins plugin that you can't mimic with a typical like shell scripting or Python scripting or other means of interacting with Jenkins. And kind of to outline some of the benefits of using plugins and hopefully to motivate you to be interested in potentially developing your own plugins. In addition to that, if you aren't interested in developing your own plugins, you can at least get an idea of what to look for in plugins that you choose. So first of all, I'll give an overview of plugins and Jenkins. So the first question is why use plugins at all? This kind of goes back to the question of why you would want to use Jenkins at all in the first place. Technically, if you look at Jenkins, you could replicate a lot of Jenkins by just taking a lot of shell script and a bunch of Python and various other languages and tying it together. But the result that you would get of trying to replicate Jenkins that way wouldn't be that good. It'd probably have a lot of bugs, it wouldn't be that polished, and it'd provide a poor user experience. And you can really apply that thinking then to why you would want to potentially use plugins. And the idea behind plugins is it makes integration with Jenkins really seamless and provides a really good user experience. In a bit here, I'll be explaining what exactly that user experience is and what it provides. So as you probably know, if you go to the jenkinsci.org, the homepage, there are currently over 1,000 plugins available. So there's obviously a lot of people developing these, and the community around plugins is growing really fast, and also demonstrate that there's demand for them and that they obviously provide some value. The other thing I wanted to mention right now is that there's absolutely excellent documentation available, both on the plugins and on developing plugins. There's a link right on the main homepage about developing plugins, and when I've done plugin development myself, that was primarily the docs that I related to. I also looked a little on GitHub for some code examples, but the actual documentation on developing plugins on the main Jenkins site is quite good. And you can basically extend nearly any aspect of Jenkins with plugins. The plugin model, which I'll describe in a bit, is very thorough and gives you quite a few extension points. All right, so before I dive into plugins, I wanted to just give a little background about myself and the way that I've used Jenkins. So I used it a bit in graduate school. And then after graduate school, I've used it a lot at the company that I joined, which is Delphix. It's about a 300-person company out in San Francisco. And we do basically database virtualization would be our core product, or as we call it, data as a service. And the idea is to provide data to people wherever they need it. And I'll be giving a short demo here of how Jenkins relates to that. So the way that we use Jenkins internally, it's really at the core of our development process. All of the automated quality assurance and testing and then the assembly of the software is all automated through Jenkins. So it's at the very core of how we develop software at Delphix. We have thousands of jobs which are run daily. Myself personally, I would say I run about 10 to 20 Jenkins jobs daily as a developer, and that's probably typical of any software engineer who's working at Delphix. We do a bunch of the 3 different things that were outlined in the keynote for how Jenkins is used traditionally, which is nightly QA automation runs that we do. We also have jobs that you kick off yourself as a developer before you commit code in order to test your code. And then also we have jobs that are used to provide bundling and packaging of software. So our software product is sold as basically a set of binaries which we package into a virtual machine and is then sold to clients. We don't have something like a service-oriented architecture that you're pushing to. Basically, we ship a virtual machine as our product. And so the assembly of all the different pieces of software that we do, since we do all the way from, we have kernel developers working at the company, all the way up the application stack to a main Java application, and then a front end, that's all done. The final assembly is automated through Jenkins as well as the testing. And we also use, it's important to point out, a bunch of other different tools. Two of them I wanted to mention were Ansible and Vagrant. We use a lot of virtual machines for our testing, and these are integrated with Jenkins as well. And then the jobs can take 1 to 12 hours. So typically pre-commit or your code check-in will take about an hour to run all of those tests, but then we also have nightly runs that take about 12 hours to run. So I just wanted to give a brief overview of generally where I'm coming from and the ways in which we use Jenkins at Delphix. All right, so the next question is, what makes a successful plugin? And so really the first question that you should ask whenever you look at a plugin is, should this be managed in Jenkins? And this slide here basically is, if you take anything away from my speech, it's basically this slide here. So Jenkins provides you a lot of different features. And with anything that provides you that many features, and as I just pointed out at Delphix, for instance, is so core to and ties together so many of your different development practices, there's a temptation to start to just pull in every little piece of the development process into it and kind of recreate the wheel with various things that already exist. So first of all, you should be choosing stuff. If there's already a good tool out there that does what you need, integrate it with Jenkins as opposed to trying to just recreate the entire process in Jenkins. And then finally, it should build around Jenkins' strengths. So Jenkins has a lot of different strengths to it. And what I'm going to do in this speech is outline several different of what I consider the key strengths of Jenkins. And it's my belief that any plugin should leverage these key strengths, and that'll give you a successful plugin. So if you're considering whether or not you want to either use a plugin that you found online, there's over 1,000 of them now, or develop your own plugin, that's really the way to evaluate it, is does this go to a core strength of Jenkins and extend and enhance that core strength? If it's outside of one of those core strengths, it might be worth considering if there's another external tool that you can use in order to accomplish that, and then integrate that external tool with Jenkins. All right, so really quickly, I wanted to then go through what I consider to be the core strengths of Jenkins. And I wouldn't consider this an exhaustive or perfect list. I'm sure if you had a debate with anyone, they'd be able to come up with what they consider their key strengths of Jenkins. The first one is organization and centralization. So basically what Jenkins provides is a central place that all of your developers, QA, and people can access in order to organize the development of software. It provides reproducible operations. You could contrast this with the idea of developers, for instance, just running all their tests on their personal laptops in different environments, and that doesn't give you good reproducibility. The other one, and this one actually gets overlooked a lot, is logging, because people just generally take it for granted. But when I'm giving this demo here of a plugin in a second here, I wanted to kind of point out why this is important. And logging basically gives you a way to understand what happened with your Jenkins job. So if you have nightly runs and something happens with your job, then it gives you a way to look the next morning and figure out if something needs to be fixed. It's kind of an overlooked point, but I think really important. Next one is archiving. Basically, most Jenkins jobs produce artifacts as a result, be they packages, a virtual machine package, or some set of binaries. And having those archived somewhere in a easy to understand structure can be quite beneficial for looking back if you need to debug something in the future. Simplicity, it has a front-end interface which will make setting up and configuring jobs easier than if you were only using, for instance, text-based config files, although those have their own set of advantages with being able to keep them in version control. Modularity, this goes to the idea of plugins and demonstrate some of the, later in the speech, some of the advantages that you get from using plugins. A graphical user interface, which makes configuring it easier. And then finally, distributed builds. So anywhere where you start to use Jenkins a lot, you're eventually going to have a bunch of different slave nodes hanging off of it because you just simply can't get one computer that's beefy enough in order to run all of your jobs. And Jenkins, if you use it from a user interface perspective, it's pretty easy to add slave nodes that you then push the Java environment onto, and you can transparently do your builds. If you look then at the way that plugin development's done, it's actually just as transparent and easy to do. It's very, very easy to make a plugin distributed in there. And I've read through a decent number of them on GitHub, and actually a fair number of them don't end up supporting distributed builds. But if you're thinking about developing your own plugins, it's actually pretty easy to do, and I'll explain why in a bit here. All right, so I wanted to do a quick demo here of a plugin that I developed, and this will just kind of demonstrate what I think are some of the key core strengths. Now, there are plugins that I've developed that are much more extensive, well-tested. They're up on my GitHub. But this one actually was only done in about 12 hours at a hackathon. And the reason why I chose to do this one is one of the ones that I've put a lot more time into is I wanted to demonstrate something that you can do in just a few hours and gets you a lot of benefits from that. And that's part of the idea that I wanted to lay, that it's a lot of work to develop Jenkins plugins or an extensive time investment. You can actually get something that's pretty good pretty quick. So the Jenkins plugin that I developed here basically connects to a Delphix engine, which is the product my company uses. Basically, I wanted to make a custom plugin to match it. So usually you can find open source plugins for a lot of your uses, but if you're developing your own internal plugin, maybe you want to make, or own internal product, maybe you want to make a plugin that goes with your internal product, in which case you won't be able to find any open source plugins for that. So just to get started here, let me reload this page real quick. And this is an instance of Jenkins I have running. And then here's the company's product here. And basically the idea behind this is we use this plugin internally for testing, a more advanced version of it than what I'm going to be demoing here. And the idea of it is to connect to one of our engines, take some source databases, and spin up some virtual copies of those databases. So first of all, I was going to show the main configuration page of Jenkins. All right, so if you see here, I added several fields to this. So there's the main configuration page. It's easy to add configuration page fields here for your plugin. It has the address of the Delphix engine. It has the username and the password for how to connect to it. And then if we scroll up here, so that's the initial configuration. We're going to scroll up then and set up a new job. And the idea behind this job is we want to do some potentially destructive testing. By that, I mean we're going to have some various resources that we use. We'll make changes to those resources and then later dispose of those resources. So what this plugin does is it just provides a way to add build steps that relate to the product. So here I'm going to add 2 build steps. And in these build steps, you can see these are 3 source databases, which can be found in the Delphix engine over here, that are automatically populated in. So that's one of the first points that I wanted to highlight is there was an API query in the plugin that went on behind the scenes to pre-populate that list. So that's one advantage. Oftentimes, if you look at plugins online, they'll just have big text boxes that you type things in. But whenever possible, try to restrict your UI. You can use API queries or other means on the back end to pre-populate a list and make it easier to set up and use your plugin. All right, so I add these 2 build steps. The idea behind these is that they're going to provision out 2 virtual databases, which can be used for testing, and then after the testing completes, it'll destroy those databases. So I'm going to save this job, and then I'm going to run it. And let's go to the running job. All right, so this is the next thing then that I wanted to highlight. 2 things here. So first of all, you see that there's some text output here that we're getting logging. This is one of the things I mentioned earlier about how people take logging for granted. So this logging actually is coming, it made API queries in order to spin up these virtual databases. If we go back here to the UI of the Delphix engine, you can see one of the virtual databases that is being spun up here as a progress indicator. But the idea behind this is that someone can just use the Jenkins plugin. They don't have to go to this interface at all. They can just use the Jenkins plugin in order to spin up their databases. And you get the log output from here. So that means that if something goes wrong with this, then you'll be able to figure it out next morning. So before this, usually we just made an API query from a bash script that spun up the database. And if something went wrong during the spin up, you didn't really know what happened. Whereas what's happening with this is we're querying the job state on the Delphix engine and then pasting that into the log output. So that's what I was talking about at the start of this speech, about how plugins can give you a really seamless experience because you can tie them in really well to all the different aspects of Jenkins. So we see that this is provisioning out here. Another thing worth mentioning, I'm not going to click it now, is if you click the cancel job, then it makes an API request to the Delphix engine to get rid of the jobs or databases that they were spinning up. We had problems with this previous to creating this plugin where we'd have orphaned databases that never got cleaned up. So it basically provides you really seamless integration and a good user experience by doing it this way. Final point that I wanted to make here is that this database spin up, it's querying the job state and blocking, meaning that it's waiting for all the databases to fully spin up before it continues with whatever testing that it's going to do relating to those databases. So you can basically delay your job until you have the databases spun up and are ready to do your testing. And let's see here, it's spun up, I believe, 2 of them now. Yeah, it's spinning up the second one here. And I'll just show the conclusion of this and then go back to talking about kind of some of the insights from this demo that I gave. All right, nearly done. So while that's finishing off here, basically just to highlight again the things that I kind of wanted to highlight from this. It includes logging. It handles cancellation. If you can't cancel things off, then you get a good result. It gets rid of the resources that you spun up. It supports cleanup, which is what's happening now. As we see from the status log output here, the cleanup's happening and it's going through and deleting the resources that it just used. The idea being is you do destructive testing to them, or you change things about them and then you get rid of them afterwards. And going back then, it also includes easy-to-use GUI features, which I mentioned is you basically just put in your login credentials and then it pre-populates the boxes in the Delphix GUI so that you can use those directly. So those are some of the things I wanted to highlight then for this particular plugin and use to go forward and talk a bit more about how you develop good plugins. All right, so just talking about the plugin model in general. So the plugin model it's a very hierarchical code base for Jenkins. Java is the primary language used in Jenkins. The other thing that's important to highlight is you can extend and override points using plugins. It isn't the sort of thing where you're creating a plugin and then sending it as a patch upstream to the Jenkins project. So you can basically take these various classes and extend and override functions and classes in order to implement the new functionality that you want. You can also, the testing is very good. So that's one thing I mentioned. I was actually having a conversation with someone in the elevator this morning who mentioned something about plugins crashing a lot. And part of that I can tell you from going on GitHub is a lot of plugins don't have tests that go with them. And if you write tests, you tend to write higher quality software. And it's actually really easy to test Jenkins plugins. So if you're writing one, I'd encourage you to look into the testing infrastructure. 2 things that are important to highlight there. There's really good integration testing where you can write a few lines of Jenkins code, and with those a few lines of Java, and with those few lines of Java, you can spin up a Jenkins interface. Do a build, assert several things while the build is happening in order to test your state, and then you have your Jenkins, entire Jenkins instance torn down and assert several things after your build completes to make sure everything worked right. So integration unit testing is made very, very easy, and there's great interfaces to make your life easier if you're going to write plugins. And also finally that you typically build and test with Maven. So one thing you might think if you're new to plugin development is that it's going to take a while to get yourself up and running, that you have to install Jenkins, you have to get a bunch of IDEs and other tools set up, and it's going to be a while before you actually start making plugins. And it's actually really easy. If you go to the documentations on the main Jenkins page, you basically just need to declare a POM file, which is typical for Maven. They give you what to paste in there, and you run one Maven command, and it pulls all your dependencies off the web, it spins up a Jenkins interface, takes your plugin that you're developing and installs it automatically, and you're ready to go with whatever testing you want with that plugin. So it's very, very easy to actually do development and get up and running quickly, which was one of the big things I wanted to highlight through this speech, is that plugin development isn't some super time-intensive task that's going to take a while and that you can't really justify the resources for. I think that's usually why people kind of lean towards just writing a bunch of Bash or Python and sticking that in Jenkins, when in fact you can often get much better user experiences if you write a plugin to do what you need. All right, so we talked a little earlier about the strengths of Jenkins. Now I wanted to relate those to a few different points, what I call leverage points in Jenkins. So these are points that you can extend in Jenkins in order to gain some benefits and improve those strengths. And I wanted to first mention that this isn't an exhaustive list, so I've wrote a bunch of plugins now, and these are just the ones that I chose that I've sometimes found to be most useful, especially if you're getting started. But there's plenty more mentioned online. For instance, just off the top of my head, one that I don't mention here is the security model. Jenkins has a security model built into it, and then you can extend that with plugins. All right, so there are basically 5 different ones I wanted to talk about. The first one is build steps. You saw that from the demo that I gave earlier, where I added several different build steps for databases that I wanted spun up before the job. The next one is distributed builds. As I mentioned earlier, I wanted to talk a little bit about how easy it is to do distributed builds when you're creating a plugin. There's also, in addition to that, logging, artifact archival, which is archiving the results of your Jenkins job, and then finally the user interface, how that works and how you extend the user interface. All right, so I'm going to talk about each of these in turn then. All right, so first of all with build step additions. As you see on the left-hand side, there's a screenshot of the build step additions that I did during that brief demo. And in order to do these, you extend something called the build step descriptor, which is basically what populates these fields over here shown on the left. That'll give you the build steps, and you can add new build steps. And then you extend something called the builder. There's actually really good documentation as well on the entire class hierarchy of Jenkins and how you go about manipulating that. That's linked from the documentation on developing plugins. So these are the points that you can extend, and with these then you can write new custom build steps that you can add in Jenkins. And so that's one of the advantages. Lots of times, as I mentioned before, you'll often see new build steps kind of added through a mishmash of various scripting, which can be good in some cases if you just need to get it up and going really quick, but oftentimes you can get a way better user experience and something that's way more reliable if you go about spending the time building custom build steps in the form of a plugin. All right. Next one is distributed builds. So as you probably all are familiar with, it's pretty easy to add slave nodes to Jenkins and then have projects get farmed out to those slave nodes. The way Jenkins works is it doesn't split the build across the slave nodes. Instead, as you have multiple jobs coming into your Jenkins server, it chooses the slave nodes and then assigns those jobs to slave nodes as they're available. So that's pretty easy. But what I wanted to talk about was from the perspective of how to do development of plugins and how that relates to distributed builds. And it actually turns out that it's just as easy as the actual interface, as the user interface normally for setting up Jenkins. It's really easy to integrate if you plan ahead, and even if you don't plan ahead and you write your plugin with one node in mind. The first time I wrote a Jenkins plugin, I just had one node in mind, and then I realized it was going to be used in a distributed environment, and I actually found that it was pretty easy to add the support for distributed builds. So there are basically implicit constructs that you can use to transparently do this. So you don't have to have a bunch of custom logic added in order to do this. What you can use are serializable classes in Java. So basically a serializable class is something that's designed to be sent across the wire so that you can basically serialize a Java class. So you basically say it implements serializable, and then that class can be sent over the wire and executed on a remote target. So you use basically declare some of your classes that you want to use as serializable. There's a really cool class that Jenkins has called FilePath. And what FilePath is done is you basically want to use that usually when you're referring to files throughout your build steps. And that allows you to basically have transparency between the file system on your master node and the remote file systems. If you basically use FilePath throughout your code, then it doesn't really matter whether or not the job is being executed on your local system or on a remote system. So it gives you a nice abstraction. There's actually quite a bit of Jenkins code that went into, if you look at the open source code for Jenkins, that went into building that abstraction so that as a plugin developer, you don't need to worry about whether or not your job is on a remote system or a local master node. And then finally, callables, which are basically just a Java class which can be called from another thread and spun up if you use that as well. So basically, the point I wanted to make is, and there's really good documentation for it online, is that it's really easy to actually make distributed plugins and get yourself a really good user experience when you're operating a plugin in a distributed environment. It's not going to require a lot of custom logic or something really complex in order to implement. It's usually just a few lines and some thought ahead of time, and you'll have a plugin that can operate really easily in a distributed environment. All right, next one is logging. So two things I wanted to point out here. First of all, logging is really easy to do, and it really benefits a plugin if you do logging, because oftentimes those logs that Jenkins generates, developers will go look at them to figure out why something went wrong with either a nightly build or some run that they were doing before they were checking in code. So logging is really beneficial. It's easy to do. It's a one-line call to write something to the log output. And then the second thing I wanted to point out, which may not necessarily be as obvious, is it's a really good idea to pull from external sources. So this goes back to that demo that I did earlier where it was pulling from the Delphix engine that I had running, which was spinning up the virtual databases. So I didn't need to include all of that log output. That log output was being included by my Jenkins job making an API call to the Delphix engine and then taking that result from the Delphix engine and including it in the log output. So the job would have ran just fine without that log output, but it's really helpful to a developer if something went wrong on the Delphix engine, then they can see that in their log output and it'll make development easier. So lots of times when you do testing with Jenkins, you'll have transient objects such as virtual machines or other resources that are going to disappear after your testing. And so therefore, having really good logs can be helpful because if something goes wrong on an external resource that's being queried via an API call, it may be hard for the developer to track down what exactly the problem was. All right, next thing I wanted to mention was artifact archival. So basically, the advantage of artifact archival is that it assists with debugging. So any Jenkins job is going to generate a bunch of different artifacts, binaries, and other such artifacts. And there's a really good system, which was not part of the plugin that I demoed, but Jenkins has a really good system for taking these artifacts and then archiving them for later viewing by developers or QA staff or someone who's interested in them. So it's a fully automated system to collect whichever results that you would like out of the system, and it's also one that can be extended easily via plugins. The other advantage of artifact archival, and this goes back to distributed builds, is you can use it with your remote workspaces in order to pull whatever artifact results off the remote build slaves that you had running and archive those for later viewing by people who are interested. And then the fifth and final thing that I wanted to talk about was user interface. So one of the advantages of Jenkins is that it provides a really good user interface for someone who's interested in basically setting up their own jobs, or if you're using Jenkins in a self-service nature. And one thing that I've noticed is a lot of plugins sometimes ignore the user interface aspect, and I think that's one of the best aspects that you get through plugins versus just attaching a bunch of your own scripts to Jenkins, is you can get really great integration with the user interface. So the way the user interface works is it's typically jelly files. They're somewhat similar to HTML, CSS. If you have experience with HTML and CSS, they're pretty easy to write. And these allow you to modify just about any aspect of the Delphix user interface. So I'm going to highlight a few of them, but basically just about any aspect can be modified. One thing that I wanted to highlight just as a general rule is try to use things that restrict the user choice as much as possible, such as drop-downs, checkboxes, radio buttons. That demo I showed earlier had a point where you selected which virtual databases you wanted spun up. And it would have been totally possible to create the plugin and just put a text box there. And then whoever is interested in using it would go log into the Delphix engine, figure out what the name of the database they wanted was, take that name, copy it, paste it into the text box, and the thing would work. But the idea behind that plugin was for it to be self-service, so no one would actually have to go to the Delphix engine. It would just run in the background as a service, and Jenkins would interact with it. So instead what it did was when you added that build step, it made an API call to the Delphix engine to get a list of potential source databases, and then used that to populate the drop-down list that I could select them from. And it just makes it much cleaner and easier to use user experience. So as much as possible, try to restrict the user choice to ones that are viable. That's not always possible. For instance, the Git plugin, which I'm guessing many people have used here, you have to specify your remote Git repository. You aren't going to be able to do that from a drop-down box. You just type in the resource. All right, and as I just mentioned, text field should be last resort. The other thing that I wanted to highlight here is that, as I showed in that demo earlier, there was some configuration that was done in the global management page for Jenkins, where you specified the Delphix engine and the username and password for what you wanted to connect to. And then there was also some configuration that was done then in the job page, when I made a new job where you could select which source databases you wanted virtual databases spun up from. And so what I wanted to highlight here is that choose appropriately where to put them. A lot of plugins that I've looked at will often just take everything and stick it in the job page, even if it's duplicated and you'll be re-entering it time after time again for when you're setting up the plugin. So as much as possible, try to split it between things that you want global to the Jenkins interface, and you can stick in the global configuration page, and things that you want local to the particular job, and you can stick in the particular job. And then the other thing I wanted to highlight is a few other areas. So what I just covered was basically more job-specific configuration, some examples from the demo. Here's some examples that I found online. So first of all, the one on the left is from another plugin that I wrote that I did not demo here, that's on my GitHub and is much more developed and advanced. So what it is a plugin for doing regression testing with Jenkins. The idea being that you want to run a small subset of tests inside Jenkins, and you just want to run the tests related to the areas of the code that you modified. So it uses an open source library called Extasi in order to do this that operates on Java code and looks at which areas of the Java code you modified, relates those then to your test suite, and figures out which of the tests that you should run in order to provide yourself code coverage. So what this does is you're probably used to seeing the blue or red flashing lights there to show you your build state on Jenkins. And what this does instead is we put a little icon in there. It's a butterfly, since that's the logo of this open source project. And that shows you whether or not that particular regression test suite was enabled when this job was run. So it's an easy way to tell whether, if it's grayed out, then the full test suite was run. If it's enabled, then it means that a subset of the test cases were run in order to provide code coverage just for the area modified. So that's another area you can modify, basically anywhere where you have icons can be modified. And then another one that I just pulled this from an open source project with the global build statistics is you can make a lot of modifications to the graphs showing the state. So you're probably used to seeing the graphs in Jenkins in the upper right hand corner, and you can make modifications to those to draw a bunch more different things depending on your states. The reason I wanted to mention this too is so I mentioned how logging was already really important. But logging can only get you so far. So logging provides you a way to look at a particular job, and if something goes wrong, then you can figure out what went wrong and act accordingly, fix the tests, or make modifications to your code. Usually people don't open the log files unless something went wrong. But outside of that, you can then, if you want more global statistics or just a general feel for how things are going, these provide this. So it's kind of two different ways of a local job nature of looking at a specific job, whereas these give you a kind of more global view of your user interface. All right, and then finally I wanted to kind of close. So I spent a while, basically with this speech, I just wanted to talk about what you can do with plugins, some of the benefits, and I guess motivate people to spend the time looking at the possibility of creating a plugin, whereas they might just go with a bunch of custom scripts. So then I wanted to kind of close with the question then of whether or not you should build something versus use something that's open source and already available. So the first point that I wanted to talk about was evaluating the time and resource constraints. And this isn't actually particularly, I would say, unique to this. This is kind of just a common theme in any form of software engineering, is that you're going to have limited time, limited developer time to develop things. And so you want to evaluate that versus just using something that's off the shelf. So it can be the case where it's something that's off the shelf, an open source one that's available, or a paid one, gets you close enough even if it doesn't provide you every last feature that you need. The next thing then that I wanted to mention though, and this is a little more applicable. This is a general, I would say, engineering paradigm, but it is a little more applicable to how you go about maintaining a Jenkins interface, for instance, as your company grows, is you should seek to continually improve. So we've at Delphix made a lot of changes to how we use Jenkins. There's a few good ones that I wanted to mention. One of them is we added a dashboard site that was written in Haskell It was completely external to Jenkins, and it was used for monitoring our build state and showing you the running builds and what their status was. It basically ended up reproducing a lot of the functionality of Jenkins, and so we had that for about a year and a half, and then we ended up eventually deciding to get rid of it and move our stuff back into Jenkins. And so I would say that's a good example of trying to continually improve and not getting tied to the particular, because there was a lot of developer time that went into making that, but we finally made the decision that it was getting hard to maintain, and we should move that process back into Jenkins because it would be a lot easier to maintain there. The other thing is the other big change that we've made is we used to have a lot of our jobs weren't in source control, and now they've been moved into source control so that they're easier to maintain there. So you don't have to get it right perfectly on the first time. This applies to plugins as well. You can choose the thing that's open source that gets you, half of the way there, 75%, use that for a while, and then evaluate what it provides you versus what you need, and eventually make the choice to go with writing your own custom plugin. So lots of times it'll make sense to go with the off-the-shelf solution to start. That's typically what I would say our company tries to do, and then to gradually iterate from there, and as we've done, start writing some of our own plugins in order to accomplish better and meet our custom needs. Also, if you can provide the Jenkins plugin to customers, that's a double win. It makes it easier to justify developer time. Not all companies are going to be this fortunate. It happens that our company, our product gets used a lot with Jenkins to interface, so a lot of the stuff that we develop internally can also be used, and we can open source it, and it can be used by developers at other companies that are interacting with our product. So if you can find any areas there, and these aren't going to be applicable for all companies, but for some companies, you'll be able to find an easier time justifying spending development time on something. And finally, you can always contribute to open source projects. This basically goes to, there's a lot of open source Jenkins plugins out there, and you can either fork one or contribute upstream to it if it's close to what you need and just needs a little modification. And then the final thing to use to evaluate building versus using something that's already available is integration with less commonly used software. And so I'm just going to use the example then of the plugin that I showed earlier in this case, which is integrating with our own custom software, our Delphix engine, which we sell, is if anyone's going to develop a Jenkins plugin for that, it's going to be internal to our company. We aren't really expecting someone in the open source community to go about developing that. So at least getting things up and running as far as the initial development of the plugin, we'd expect to come from inside the company. And this may be the case in other companies where you have your own internal product, in which case it's more justifiable to spend the time building it since you can't find that in the open source. So anyway, in summary, basically, wanted to go back to kind of close with this slide that I had earlier, which is what a successful plugin should be. And it basically, you should start by asking the question of whether or not something should be managed in Jenkins. And then if you do build a plugin, it should be built around the strengths of Jenkins, which I believe to be these strengths. And if you can tie a plugin to one of these core strengths and build around it and improve these strengths, you'll have a successful plugin. Thank you very much.